So over on this Excel spreadsheet, what I have are the data from the community spread cases, which I have obtained from MOH. There are data before and after the start of circuit breaker. So I have 4 weeks after the week which we start our circuit breaker that I have indicated in yellow. Then the week which circuit breaker has extended is indicated in orange. So circuit breaker start on 7th of April, which is a Tuesday. So there are 40 cases on 7th of April, 8th of April, 9, 10, 11, and so on. So what we are going to do today is to learn how to use Excel to calculate average. Standard deviation actually is not very important for our t-test, but I will also show you how we can do this. There's a f-test that you see down here. I will explain to you why we need f-test for our t-test. For our t-test, we will get a p-value, which I have explained. You can just take it as the probability that the 2 weeks data are the same. So to calculate average, select the cell that you want the average to appear. Double click on it so you can type something on it. Do not type rubbish. You want this cell to be equal to average. So you open bracket, what are your data? You select the data, which is this week, and close bracket and type equal. Excel will calculate it out for you. Now, it is very tedious to type in for everything. Don't worry, Excel is very easy and friendly. Click on this cell. You can see a green color square down here, and you can drag it. So drag it to your last week, and you will calculate all the average out for you. If you want your data to have less decimal place, because maybe a lot of decimal place is very messy, what you can do is click on the decrease decimal places. So we click on this, and your data will look neater. For standard deviation, it is very similar. You just have to type equal standard, ST for standard, then deviation, DV. Now, normally the data that you obtain is actually from a sample. But in this case, we are obtaining from the whole population. So we can type .p for the whole population. But like I said, normally it's just a sample. So you type .s rather than .p. This is quite a unique situation whereby it's the whole population of Singapore. And where are all the data is down here. Close bracket. And we will get our standard deviation. And like I said, by pressing the decrease decimal places, we can make our data neater. Now, it's important to take note that we actually do not need the average or standard deviation to calculate t-test. What is useful for us to have the average is to make some graph like this. Then we can see the trend. So this one is for you to explore. We will not talk about graph representation today. So let me delete this graph. The next thing that you might notice is hey, didn't our Minister Gan says that on the circuit breaker week, the average is 39? How come it is 41 down here? The following week is 29, which is correct. The simpler explanation will be because for Mr. Gan, his week actually start on Monday rather than Tuesday, like what I have done. Because Tuesday actually makes more sense for the reason which I have explained earlier. But for Mr. Gan, he just make it easy for everyone, so he just take Monday. So for his data, the week he's referring to is Monday, Tuesday, Wednesday, all the way to Sunday. And I actually have the data down here. So for Mr. Gan, his data is from Monday to Sunday, Monday to Sunday, which is why he said that the average cases decreased from 39 to 29. In the grand scheme of things, if you ask me, is the slight difference going to make a difference? I would say, I don't think so. So he can make it simple for the whole population of Singapore by using his analysis from Monday. Just that I think it makes more sense for us to start on Tuesday due to the time it takes to diagnose people as well as the symptoms to appear. Now, if we want to do a t-test, click on the box and we can type equal t.test. Open the bracket, then you will be asked to key in array 1. Array 1 is just the first set of data, comma. Array 2 is the data which you want to compare them with, comma. Now, you get to choose one tail or two tail. Like I have explained earlier on, your normal distribution graph, you have a 95% interval. On one tail is 2.5% and at the other tail is 2.5%. So together they will make 5%, which is why we are going to use a two-tail test. For one-tail test, you can use it if you are very sure that one data should be higher or lower than the other. For us, we try not to be biased, so we use a two-tail test to give leeway whereby maybe circuit breaker have caused an increase. And using a two-tail test also make this a stronger test. Stronger meaning more reliable, because the percentage or leeway you give is lesser. So go ahead and pick number 2, which is two-tail test. Then you are presented with the type of t-test that you want to do. Whether you want to do PET t-test, two sample with equal variance, or two sample with unequal variance. Now, we have not talked about variance, and you might not know whether these two samples have equal variance or not equal variance. We can find out whether the variance are equal or not just by doing the F-test. As for PET t-test, the choice number 1, we will use PET t-test when there is association of first set of data compared to the second set of data. For example, let's say you have a class of students, the height when they were in Set 1 and their height when they are graduating in Set 4. So this is where it makes sense to use PET t-test, because let's say Tom, Dick and Harry, you pair Tom height in Set 1 with Tom height in Set 4. You pair up Dick height in Set 1 and Dick's height in Set 4. Harry Hyde in set 1, Harry Hyde in set 4. You pair them up together to see whether the average increase in height of the class is significant. Because there's a relationship between the height of a specific person to his height when he is graduating. So that's when we use PET t-test. For this analysis, it doesn't make sense that Tuesday number is tied up with the next Tuesday number. So we are not going to use PET t-test. We are either going to use two samples with equal variance or unequal variance. So for now, let's take it as they do not have equal variance and we type 3. Okay, then we close the bracket. To find out whether they indeed have unequal variance, we do a f-test. So go to the box where we want the probability to appear and type equal. This one is a f-test, so we type f.test. Then the array, this data, comma, this data. Close bracket, we will get this value. So let me just write p equals, because they are p value. So what this means is the probability of these two samples having equal variance is 0.26369. So as I have explained earlier on, the threshold where we say that there is significance difference is 0.05. So since this is higher than 0.05, we say that there is no difference in the variance. So we need to change the unequal variance to equal variance. And this will be our probability that the data from this week and the number from this week, their average is the same. So we can see that the average of this week is 32, while the average of this week is 21. The probability that they are the same is 0.01. So the chance is actually very low. So in this case, we can say that this week and this week, the number have actually significantly increased because they are statistically significant. And same thing, I can just drag this across. We will see that these 2 weeks, the variance is equal. This 2 weeks, the variance is equal. This 2 weeks, the variance is equal. In fact, all the week, the variance are equal. This one, there's nothing for me to compare because we still do not have the future data. So let me delete this. And since the variance are equal, we can just drag this all the way here. Then we will see which week the decrease or increase is significant. So this one is the result of the t-test. So as mentioned, so the fortnight before the circuit breaker, we can see that there is a significant increase. Then, from the week before the circuit breaker and the circuit breaker week, there is actually no significant difference because 0.09 is actually higher than 0.05. So even though you might think that, oh, it's 10%, it's very small, but still, we are not confident enough to say that these 2 weeks, the number have actually increased. Statistically speaking, they are actually the same. So let's look at the circuit breaker week and the week after. So remember, keep in mind that the people down here, they actually caught the disease on this week, while this population actually got the COVID-19 on the circuit breaker week. So is there a significant decrease? So the probability is 0.02, there's no decrease. So we can see that circuit breaker actually works because the decrease in number is significant. And the decrease is also significant from the second week of circuit breaker, because on the third week of circuit breaker, we see the impact of the second week. So you can see that comparing the second week and the third week, the probability that they are the same is 0.017, which is less than 0.05, so they are significantly different. So the number have dropped even further. So since the number have dropped significantly, maybe circuit breaker should not have extended. This one is up for you to debate, but let's move on. So comparing the circuit breaker, the extension of the circuit breaker, because this one is announced this week, then we will see the effect this week. Did the extension cause a significant drop from 19 to 9? We can see that statistically speaking, it is actually very, very unlikely that there's no difference. So that we say that the decrease is very significant. So the enhanced circuit breaker has actually made a more significant decrease in the number of COVID-19 patients than the initial circuit breaker. So maybe it's a right choice to enhance the circuit breaker. Next, we move on to the last 2 weeks, which is this week or the time I'm recording, as well as the previous week. We can see that the number is actually 9 and 8, and it's not surprising that the probability is higher than 0.05. So for the last week, there is no significant changes. So for the last week, the decrease from 9 to 8, it is not significant. There's no significant decrease. So what's the take-home message? The take-home message that we can see is, from this week to this week, since there's no significant difference, if nothing had been done, maybe the number will continue at this region. But since we want to flatten the curve, I feel that it's a correct choice to have this circuit breaker. We can see that the number significantly decreased. And 2 weeks into the circuit breaker, the decrease was still significant. A few reasons. One of the reasons could be there are lesser carriers to spread the virus. And the enhanced circuit breaker has caused the number to decrease even further. However, we may have come to a point whereby there might not be a lot of room for decrease. So maybe things can be lifted up earlier, at least from this single statistic analysis. However, if you ask me, if I look at the situation in other countries such as South Korea, Hokkaido, I probably would be sitting on the safer side and say that let's hope that there is no cases for 2 weeks before we go back to normal. And like what the minister have been saying, the normal will not be the same. So this is all for how you can analyze data using t-test on Microsoft Excel.